In your body, you have the cardiovascular system and respiratory system, and together they work to supply oxygen to the body and get rid of the carbon dioxide the body makes. The main system that is involved in this process is the respiratory system. When blood that is high in carbon dioxide but low in oxygen reaches the heart, the pulmonary arteries pump it to the lungs. The lungs expand when you breathe in oxygen, which transfers the new oxygen through the alveoli to the low oxygen blood and also sends some of the carbon dioxide back to the lungs. This process is called gas exchange. That blood now has fresh oxygen in it, so it can go to the heart to be pumped out to the rest of the body. In the body, there are three energy systems. The first is known as the ATP system, which is the system used in high-intensity sports or activities. It is only for short intervals of time, like between 1 to 20 seconds, so activities in sports like football would use this energy system because, say for an example, you are a defender running to attack a player. You engage in short but fast sprints. The ATP system gets its energy from the ATP stored in the muscle cells. There is a small amount of ATP in the muscles when they are not engaged, which is why the ATP energy system only works for a short duration. System 2 is the lactic acid system, which is used in high-intensity activities or sports, but for a slightly longer duration than the ATP system. Lactic acid is produced in the muscle tissues during strenuous exercise, which can often cause sore muscles the next day. The lactic acid system lasts between 30 to 60 seconds. Unlike the others, the lactic acid system does not require oxygen, it requires glucose. Glucose is the process which comes from either glucose stored in the blood or from the breakdown of glycogen in the muscles. The lactic acid system creates a byproduct known as lactic acid. When there is too much lactic acid in the muscle cells, it can cause fatigue and can also cause a decrease in intensity. The last energy system is called the anaerobic energy system, which is for low-intensity sports/activities that last over 2 minutes, meaning it is for long durations. This energy system needs glycogen and oxygen because the glycogen is converted to glucose, which is then broken down by enzymes, and the oxygen is needed to keep the blood circulating through the muscles that will be engaged for a long period of time. When playing football, the body undergoes short-term and long-term responses. A short-term response that you notice is sweating. Sweating is the natural way of cooling down your body. In football, you are using the ATP system or the lactic acid system, depending on how you play and or your position, which means you are working at a high intensity, causing the blood to be pumped faster through your body, ultimately increasing the temperature of your body. Sweating is your body's response to help keep your body at a maintainable temperature so that you can continue playing consistently. Another short-term response to playing football is muscle fatigue and aches. If you use the lactic acid system when playing, your muscles will begin to feel sore because you will be playing at a high intensity for the duration of the game, which means there will be a buildup of the muscle's byproduct, lactic acid, which causes muscle aches. If you are a football player, you must know that you have to train and exercise to perform at the peak of your ability. Because of this, your body undergoes long-term responses like weight loss. You lose weight when doing sprints so that you are able to use your ATP system in the game. Also, the fat in your body gets used up as energy while exercising, which ultimately helps you to play with more intensity without tiring yourself. Another long-term response is your lungs increasing in size due to the fact that your body needs more oxygen to go to the muscles you are working when you're exercising. This also means that your muscles get bigger because more blood goes to the muscles so that they can perform properly, and to get the blood to the muscles you need oxygen to get to these muscles. The bigger the muscles, the bigger the lungs because of the larger amount of air that has been needed to transport blood to the muscles.